the important part of this lecture is to focus how to give names and how to understand the classification with regards to Malaysian soil, actually. So if you have like lecture from YouTube and also from other lecture slides, theirs is mostly focused on either United States or maybe India. So I have searched the internet, I've searched YouTube. Majority of the lectures given is either in US or India. But for today, we're going to learn this one according to Malaysian context. So soil classification, we can see right there is actually what your seniors have done last time. 2 years back, they were like in soil sampling activity. So one of the activities that they did is to dig up a trench like that, up to 2 meters deep. So it's quite bone breaking, like to say. Up to 8 males were asked to dig this hole, this trench, and they took 2 hours. So they did it. We managed to find out valuable information regarding the soil horizon. That's what they did. And most of the time, you're going to hear names like, the names of the place regarding to the soil, like what you can see right here, the right-hand side, Kuantan series. It's not Kuantan soil, Kuantan series. Now, Kuantan series is one type of the soil series that is available in Malaysia. And say it's referred to Kuantan, but it's not just limited to Kuantan. Other places may have some similar characteristic as this soil, and which is why they were classified. Now the characteristic is quite different compared to different series. So this is what we're going to learn slowly, lah. I know there are many series that you're going to learn, but take it easy, yeah. Now this is the outline. What we're going to learn is the origin and classification of Malaysian soil. Now, the basis of this is mainly due to the changes that happen to the soil. And based on that, we're going to name it accordingly. So again, we're going to look at Malaysian soils only. The distribution of Malaysian soil. Where are the locations and how much does this soil consist in with regards to Malaysia? So we're going to learn a little bit, not much. And then lastly, soil suitability classification. So at the last part, we're going to learn how do we classify soil. This is very similar to water quality index that you learn, but this is a little bit minor because water quality index, as far as I know, is the major part that you need to learn in water resource technology. But for this one, we're going to learn class 1, class 2, class 3, class 4, until class 5. So we have also 5 classes. And then we're going to discuss a little bit what are the suitability of the soil and what else we can do towards the soil. So I can tell you, majority of today's class will be consist of the first point, origin and classification. Okay. Now, this flowchart summarize our lesson today. Now, most of the naming or classification consists of these 2 parts. So soil, in terms of soil taxonomy, divided into 2 parts, either mineral soil or organic soil. Now, as what we've learned earlier, these 2 soils are quite different in terms of their chemistry and also their character, and which is why when we give them, assign them with a different soil classification, of course, we're going to divide them accordingly. Now, for mineral soil, we all know that it comes from bedrock, rock that are come directly from lava, and even rock also have several types: sedimentary rocks, igneous rock, metamorphic rock, and from there, due to weathering and also erosion, and they can be further broken down into sedentary soil, reworked soil, and also alluvial soil. Now, I think this word you have learned it before when you learned geography before, tanah alluvial. So you also know this is coming from erosion that you can find from lowlands, erosion that happens on higher ground, and then they slowly flow with the direction of river, and then they settle in delta. So alluvium is what we usually refer to. What about reworked soil? Now, reworked soil is maybe one notch less mobile than the alluvium. Now, they are actually coming from the weathering process. On the other side, if alluvium is due to the erosion, due to movement of soil from one place to the other, sedentary rocks is due to weathering. Do you remember what is the difference between weathering and erosion? Okay, erosion, the movement of soil away from its original location. Sedentary, they are broken down, but they never move. Rework is in between. That's what I can say to you. Now, I strongly encourage you to find out what are the other types of soil that involve, what type of other names that involve under mineral soil. Now, whereas coming back to organic soil, now organic soil, not much of classes coming down from that. Now, usually organic soil are usually divided based on how deep is the organic soil profile. So based on different depth, then you have these different series. So majority of the soil series, they consist of mineral soil. Organic, they have some, but not that much. Yeah. Which is also what you're going to see later on the slides. Majority of the slides that we're going to learn are due to mineral soil. Now, first thing first, why do we even need to classify soil? Now, most importantly, soil is being used differently, and that is why we need to classify the soil. It's just like water. You can't use wastewater for drinking purposes. It's the same with this one. We don't use uh, degraded and very polluted soil for agriculture. And initial purpose of this soil classification are based on two. Now, you've learned history of Malaysia. At the very beginning, what drives Malaysian economy? There are two. One, agriculture, of course. The other one is mining. And based on these two soil classification, the early pioneers of Malaysia, they need to know this kind of information so that they have better information on how to use the soil and extract the mineral or maybe have a higher productivity in soil. Because obviously, when you want to extract mineral, you don't have to mind about the nutrient content. However, when mining happens, the nutrient content is lost and you have to think about it. You cannot use all soil for agriculture. You have to do something. And that is why majority of the soil classification happened in the 1970s. I will show you one of the Malaysian map, where the first part of the classification was completed in 1970s. Yeah? So done with this one. Why is so important? Once again, most of the time is due to agriculture. So soil survey. Now this is actually an activity conducted by Jabatan Mineral and also with a collaboration with the Department of Agriculture. So both of these agencies very early on in the 1970s or probably much earlier, they have conducted several activities on exploration, I would say, on finding out the characteristic of soil. So this is what we call soil survey. And I'm not kidding you. They went from the entire Malaysia. Of course, when they say the entire Malaysia, they are not finished in several years. And if not mistaken, this study has been conducted for the past 30 to 40 years. And guess what? Soil is not permanent. They change over time and they change with human activities. So this survey has been like repeated several times. How many times I don't remember, but at least two times. The first that I remember is 1970s, and then very recently several times that I'm not too sure how many times, but they were repeated. Yeah. Because why? Because soil change due to human activities, and to have a better idea what are the soil characteristic and quality over time, this has been repeated many times. So this is the map that I told you earlier, the first soil survey that is conducted by the Department of Agriculture. Why? Because this year, 1970, this is the time also Tun Razak was the prime minister. And during his time as prime minister, he actually encouraged agriculture activity as a main source of economy for Malaysia. So of course, you want to plant something, you have to make sure that the soil is suitable. And therefore, the first thing that needs to be done before planting happens is to find out what soil do we have. And this is in 1970s. Can you use it now? Of course you cannot, especially those nearer to coastal area. And those in the middle, like in Banjaran Titi Wangsa, maybe not much of human activity, so you can say it remains more or less the same. But those that are nearer to populated areas, yeah, they change significantly. This is only correct in 1970s lah. Yeah. So if you can enlarge this one, I strongly encourage you to look at this and then find where is your current location. After this, you will need to go and find where is your nearest location and find out in 1970s, what are the soils in your kampong. Remember, you need to do an assignment? Yeah, that is why. This is what happened in 1970. So you have half of your assignment right here. Okay, what you need to do for your assignment is find out what happened nowadays, today. What happened? So obviously something changed, right? So your job is in your assignment to discuss 30 years before, I mean 40 years before that. This is what happened. After 40 years, something changed. So you discuss lah, what are the human activities, and then what changes the soil characteristic, and what do you think? What do you think is the current soil? What kind of soil classification today for the soil in your kampung? Okay, so before I leave this slide, just an info. This soil map is is developed by the Department of Agriculture, and they are the custodian of this information, so-called data. Now, if you have some spare change lah, you have your duit raya after this, right? So if you have 20 ringgit, you have had 20 ringgit, you can contact the Department of Agriculture and ask them to give you the latest soil information. If you have money lah, if you don't have, then no problem. You can always find it from Google, plenty of information. But if you want the latest data regarding the soil classification or the soil quality near your area, for example, pay 20 ringgit to Department of Agriculture and they can send you that data, the latest, yeah? Okay. So the basis of classification, of course, is due to the changes of the soil, due to weathering process and whatever that happens, although that includes the organism or vegetation that has on top of the soil, because over time vegetation also may change the soil characteristic. Now relief is the soil topography, I mean the shape on the soil surface. Because why? Based on different shape, weathering also happens differently. Weathering or erosion, whatever you call it. Parent material as well, because not every soil is created the same way. Some of them may be due to different composition. If you're sedimentary, they may erode much faster than the igneous rock, and because of that, they also change differently. And of course, time. So the longer the time subjected to the erosion, then the soil will become more mature and more, say, more oxidized and more weathered. So more weathered soil, they have different classification. Okay, now the first keyword that you need to know right now is, um, what do you call the smallest unit of a soil area? We call it a pedon. Now, it's not that you need to remember that much, because I remember that I don't use this word that often. So, well, this is just for your info lah. The smallest unit you can call. What kind of pedon? Okay, if you take a school of soil, yeah, or you can call it a pedon. How big is that area? Approximately 1 square meter. Square meter is actually quite big, the area. So that is an area that you call a pedon. Now, in order to classify a soil, it is not as easy as we have discussed earlier. Because why? When you say you want to see the soil characteristic, we have three, right? Physical, chemical, and biological. Now, in order to find out the chemical characteristic, you remember how many experiments that you did for soil lab? 8, if not mistaken, 8 or 10. And then actually, these are not all the experiments that you have to do in order to classify a soil. There are many more actually. So I know. Well, if you want to say you want to classify your soil in your kampung, then how do you do it? Well, most likely you cannot do it, and you have to rely on literature. Because why? You have to do a lot of diagnostics. Now, when I say diagnostics, that includes you need to determine soil particle size distribution. Probably that's one. Maybe you need to do soil pH. These two requires you to use chemicals, reagents, or maybe some specific instrument to know the exact value. Okay. Now, the best you can do at home is probably what you can do already is probably soil color. You can do soil color and determine that. You also can do soil texture. These are the things that uh, that the scientists use to determine the soil characteristic and to come up with the proper classification of the soil. Now, once this information has been obtained from the lab, from the soil lab, so this information you need to compile. After you compile, then slowly you play puzzle. Well, not exactly play puzzle lah. Because what, you have all these more piece of information, and then in order to find the soil order or soil classification, you have to piece this information together. Okay, like there are many examples. It begins with soil order. So because there are 12 soil order, at each of those soil orders, they have very, very distinctive soil characteristic. So based on this information, you determine the soil order. Then after you determine the soil order, then slowly you come down. You come down and determine what is the name of the suborder. And suborder, what do they address? They will probably going to look at how much of moisture inside the soil. So based on the moisture, then you can come up with the suborder name. Then it comes down, it cascades down. So you can say that soil classification is quite tedious. You need a lot of information, as much information as you can, in order to come up with the most accurate soil classification. Yeah. And then, of course, the last point. The last point, I probably won't force it on you. This is the soil taxonomy and nomenclature. When I say taxonomy and nomenclature, uh, put it this way lah, easy. This is the language of soil science. Yeah. You know the language of science, kan? Language of science, usually they use a lot of Latin nomenclature, words from Latin or word from Arabic. Well, from soil, we have a different set of language, yeah? So I know there are many nomenclature that if you really want to know, there are many, up to several thousands. Even I myself also don't go and memorize them. So if you ask me whether nomenclature will come up in your examination, I would probably say not much, but I will still keep one question. So this, I give you the tips already. Like, I probably won't going to ask in the test question. Okay, what is this term means? I probably won't ask too many of those questions. Even if I do, 1 mark. Okay, they will be one of these questions, but it will have just 1 mark. Okay, so don't waste your time. Go and memorize all these nomenclature. But here's another tip. No matter what I ask in terms of nomenclature, I will mention during my lecture. Yeah. So this is your tips, huh? Don't say that I didn't tell you. Okay, now typical soil features and characteristic for classification. Now, in in order to classify the soil, there are two ways that you can start doing this. You diagnose the surface soil or you diagnose the subsurface soil. Now you have to do this at once so that you know exactly what characteristic on the surface soil, and then how do you give them and how do you assign those soil order. Because why? Uh, Based on weathering process, the more extensive weathering process that is subjected on soil, the more horizon that you get. Now uh, that is a consensus that people have. More weathering and more horizon. And based on that one, then you can better assign what kind of soil order that is. So usually, the first part soil scientists that we're going to find out is the information regarding surface horizon or surface soil. Or in other words, we call it epipedon. Pedons is a soil. Epi means outer part. So we find out the information because actually that's very handy. That's the first part of the soil that you can get access to. Yeah. So you can see in this table, 5 horizon, A, E, B, C, R. So this, oh no, 6 actually, I forgot. On top of here, there's also one more horizon, O, A, E, B, C, R. So these are the six soil order, I would say. Not soil order, soil horizon. Okay, these are the 6 soil horizons that you must know the alphabet, you must memorize, and also its correct order. So what starts first? O horizon. Or you can say it represents organic whatnot, because usually the outer surface are usually littered with organic matter, either from trees or from dead animals or their feces or manure. So usually the first one, the first horizon will be O horizon, then followed by A. Now A is, you can call it a mineral soil, but in this mineral soil usually is dark in color. Because why? Because on top of the A horizon, there's O horizon. There they will break down. What not? I mean, organic compound, they break down all the time. So what happened after they break down? They travel with the direction of water due to gravity. They come to the A horizon. A horizon is mainly mineral, like sand, maybe clay, but they trap a significant amount of organic matter. That is why A is mineral, but it's dark. O, probably not much of mineral. It's just mainly organic matter or decaying organic matter. So moving deeper is E horizon. What is that? That is mostly mineral with a lot less organic matter. So if you compare the color between E and A horizon, E probably is a lot whiter. Why I say white and not yellow and not orange? Now, most of the time when you see soil, they're usually orange in color, isn't it? Not chocolate. It cannot be chocolate. If it's chocolate, that means it's still A horizon. They still have a lot of organic matter. E is usually mineral, and usually mineral do not have color, except for basalt. Now, basalt is the only mineral that is black in color. The rest of it, white, yellow, maybe red. White is due to the lack of pigment. This pigment usually is transition element. Now, why are you looking at clay as red in color? Now, clay is red because they have iron. Iron is red, so that's why you see it as orange in color. Now, if they have erosion, as what you can see right here, they leach down. So once they leach, they also were going to wash away all those iron. Where to? To the next horizon, the B horizon. So if you compare the color between E and B, B is usually a lot more intense, the color, usually red lah. What about E? Usually they're either white or yellowish. B is more, because why? E horizon, they have erosion, they leach down, and those iron are accumulated at B horizon. How deep is B horizon? It's usually between 1 meter to 2 meters deep from the surface lah. Now, this is not the end, because it can also extend to the sea horizon. Now, sea horizon is the mineral soil that is not much of that has not much of development. Development here means weathering. So you can say sea horizon, you can find gravel, some stones, larger rocks. Now, these are due to the fragments from the bedrock. Bedrock is all one whole slab of rock, as if like it's just come up from the lava, but no, this is like a bedrock. So they will weather into smaller pieces of small piece chunk of rocks. So they will sit in sea horizon, and you can see the deeper you go into the horizon, the larger the particle size. And the higher you go to the horizon, the smaller the particle size and the more organic matter it will accumulate. Now, based on these different characteristics, there comes the subhorizon. So what are these subhorizons? Now, usually these subhorizons are smaller letters. Now, these small letters are usually paired with the capital letter. So do you see the difference between horizon and subhorizon? Yeah. Horizon, usually they're represented by these 6 capital letter, O, A, E, B, C, R. Subhorizon is used only if it's needed. Now, not all horizon we're going to have this one, but I can say lah, most likely they have. For example, now in the B horizon, when you have leaching happen on top, for certain they're going to accumulate some particles, usually the smaller ones lah, like clay. And with the accumulation of clay, usually the B horizon will going to pair with a small T letter, T, right here. So this T letter usually is associated with B horizon, at least in Malaysia, because you know what? Malaysia have high rainfall. So accumulation of clay due to erosion, vertical erosion is not really that surprising. T is right here. And what T means, after this you can see like, T usually is associated to accumulation of clay and also mineral. So what this mineral is? Probably aluminium. Most likely is due to iron. So BT horizon usually is the main example for Malaysian soil. Yeah. And as you can see right here also, the description, mineral soil in which leach clays have accumulated and other soil development process have occurred. And this is actually the description for T, this small t over here. Not the entire thing, you know. This description right here is accurate for this small t letter. So after this, you're going to see a lot of our discussion. You're going to see BT horizon. That means this B horizon has been accumulated with clay from the E horizon. Okay, so now back to your concern. I know a lot of students right here probably say, oh, do I need to memorize C, F, G, H, K, N, and every single thing? The answer is no, because I know you're not computer, you're not supposed to memorize these many things, kan? But here's the thing. If I want to ask you any question in test and examination, it will be related to Malaysian soil. So is that a tips for you? It is. It does sounds like a tips for me. So I hope you pay attention, yeah? If I want to ask you anything about this master horizon or sub-horizon, it will be related to Malaysian soil. Okay, I have done given you my tips. Moving on. So these are the things that you want to memorize, go ahead lah. But like I told you, only those relevant to Malaysian soil, yeah? Okay. So I won't go to talk too much lah. Now, just now I said that it's all started with the epipedons, right? So here are the words, okay? So diagnostic horizon. Now, molic soil, what does it mean? Molic, after this, you're going to see also this word, molic, when we categorize, when we classify organic soil. This word will appear again. Now, what does molic means? Molic means thick, dark-colored, well-structured, high CEC. And these are the language that soil scientists use. When we want to describe a soil, if we want to describe a soil that has this kind of feature, we don't use all these words. We just put molic soil. That's it. So yeah, you can say today's lesson is more or less like bahasa, a language class. But this is the language for soil scientists. So don't be surprised lah when you see in your literature review. I know a lot of you have already started with your assignment to find out what kind of soil that your kampong have. So if you can find information, guys, some of the papers, scientific ones, you're probably going to see this one. I'm sure you're going to see this one because Malaysia, most of Malaysian soil, we are having this kind of characteristic. Okay, the other one, ochric. Too light colored, too little organic matter, or too thin to be molic. So this is like the opposite lah. Either you have organic matter or you don't. So these are the words that, yeah, sometimes you will see in the research paper. And then there are just now was two major. Now these are the 5 minors, I would say. Okay. I think we're going to take you through just very simple. So following on what we've discussed just now on the two major epipedon, the diagnostics. So these are the rest of it. Anthropic, what does it mean? Anthropic, the words itself already indicate that anthropology, that means human intervention. So you can see here, anthropic epipedons means human modified molic light horizon. And guess what? Yeah, this is another major word that you can probably use a lot because majority of Malaysian soil, they are already human modified. How? Depends lah, yeah. Histic epipedons, very high in organic matter, periodically wet. So it's related mostly to organic matter, high or low. And again, these are the diagnostics epipedons that is probably quite relevant to Malaysia due to the high rainfall and also high organic content. Then melanic epipedons, thick black, more than 6% organic carbon, common in organic soil. So you can see that if you are sitting in areas in high rainfall and in high organic matter, for example, in Sarawak, near Kuching, you're probably going to use a lot of these words lah. Because Kuching, near Sarawak, is known to have a lot of peat soil. So if your kampong is dealing with a lot of peat soil, so these are the words that you're going to play a lot. What about the others? Maybe not much lah. I can say that all these surface epipedons, they are usually associated to organic soil or peat soil. What not? Look at it, all organic. And plagan and umbric. So these are the two words that is used to describe plagan, used to describe human-made sodic-like horizon created by years of manuring. Do we have this? Not much, I would say. Not much. Manuring usually is the practice used in countries that have intensive agriculture. Now, in Malaysia, we used to have intensive agriculture, but during 1980s, all that stopped already. So I'm not sure whether this is available in Malaysia. But as far as my concern, due to Malaysian economies, I don't think this is very apparent. Because why? Usually this soil, I mean this epipedon, I mean this diagnostic will be used majority for any soil that have a long-term manuring. I'm talking about maybe 30 years and above. Does Malaysia have 30 years of history of agriculture? I don't think so. I don't think so. Yeah. So not likely like you're going to use it. And then finally, umbric soil, same as molic, except for low CEC. So this one, although sometimes you can find high organic matter, but for some reason that we don't know, they have low CEC. Well, this might happen also. Yeah. Okay, now I think I want to skip this part because I know the more that I talk about this one, you're going to fall asleep. So I'm going to leave this diagnostic subsurface horizon to you for you to find out. Because you know why? If I want to give you lecture, I'm going to give you the short one and the one that is mostly relevant for your test and examination. Okay, I cannot say this is not relevant. This is still relevant. But to save time, I will skip this and I will ask you to read it yourself because there are too many for me to explain one by one. I just need your consensus. Do you agree or not? I leave it for you. You read it at home. Can or not? Response, please.
And
Yeah. Okay, now, one more time. Yeah. I did not say this will not come up in your examination. It may, but very small portion. So you have to go through also lah. Yeah.